Okay, so hello everyone. I'm really happy to be here. I hope you're all having a good time. I certainly am. It has been a fun conference, my first time in Chicago. So as I was reading like the brochure we were all giving yesterday, I saw there's like a lot of people involved in organizing the conference. So I want to thank all of them. I know organizing a conference is really tough, and they've been doing an excellent job. So my name is Sebastian. You can find me as Sebasoga in Twitter and GitHub. You already know that I'm from Colombia, and I really hope this is not the only thing you know about Colombia. It's a shame if you do, but it's not your fault. It's Netflix's fault. In case it is, like, you should definitely come and talk to me afterwards. And also, like, since we're talking about Colombia, like I mean, a group of people are organizing a conference in Colombia. We've been doing it for 2 years. This year's conference was 2 weeks ago. It was pretty good. That way you could get to go to Colombia, especially to Medellin, where that's supposed to be recorded, and see it yourself. Actually, Ray was a speaker there last year, so you might get a chance to ask him what he thinks about it.
It was awesome.
Oh, he's there. Great. Thanks for the support. Okay, so this talks about TCP socket programming in Ruby. So before all of you open your laptops, let me tell you like the two main reasons why I think this might be important. So the first one is because you might want to learn and understand a little bit better how HTTP works and how your application communicates with your users. Or also because, like in my case, sometimes you need to integrate it with another piece of software or hardware that communicates at TCP level. It's not that common, but it happens. So before this actually happened to me, when I heard the word API, like a lot of words came to my mind, such as, like, for example, REST or JSON, or some other words I don't really know how to pronounce in English. So XML is easy. This is SOAP. I don't know. WSDL. I don't know how to pronounce that. You can read, you understand. So anyway, when I got like the document about what I needed to do, like kind of like the API that I needed to integrate with, I was like, TCP? Really? Am I back to school? Is there like a hidden camera somewhere? Is this a joke? I was lost. And it didn't help when I saw that I needed to use something that's called like a line protocol, nothing fancy. It's just that I needed to send a message that kind of looked like this. It was like really specific. So we had like specific stuff that needed to go in the header. Then it needed to have an empty line. It was very important. And then it was kind of the body, where the first word was like set, basically like the instruction you wanted to set to the hardware we were using. And then like a bunch of key value pairs where you could set stuff, and like an optional timestamp at the end, which I didn't really understand why was needed. It was actually optional. And something that was really curious to me is that like it was mandatory to, it was really important to have 2 blank lines at the end of the message. Otherwise, the microcontroller wouldn't know that the message was done, or basically that you were done sending its like data. So if you only added once, like it happened to me, you would leave the connection open, and the microcontroller wouldn't be accepting other requests that needed to respond to, and the request queue that the microcontroller had was really small, so basically it started refusing a lot of connections, so that was bad. But that's enough complaining for me. Let's start from like the beginning. So what's a socket? So like the simplest explanation I could think about is like that sockets are like endpoints of bidirectional communication. You could also say that basically that sockets just speak to each other using a standard Unix file descriptors. And this is pretty cool because like if a socket can get a reach of another socket, it doesn't matter if that socket is running on the same machine or in a machine like on the other side of the world. They will communicate. Of course, there might be latency, but they will communicate. I mean, it doesn't matter if they're far away or close. That's pretty cool. So basically, how I saw this when I was kind of getting into this is like two friends that have like this secret handshake. Cool, right? So going back to the subject, sockets fall within like one of the defining features of Unix, where you know that everything's treated like as a file. So that means that like a wide range of stuff that has input and output, such as like documents, directories, hard drives, printers, keyboards, they just like share streams of bytes. They're considered kind of like the same thing. So yes, you could say that sockets act like files. Which is pretty cool is that if you have dealt with I/O type of objects in Ruby, you already know how to deal with TCP sockets. That's it. Okay, I'm joking, of course. I know you want to go have lunch. I'll try to be short. So, oh, by the way, the timer is not running, so I'm not really sure how much time I have. Oh, okay. Okay, let's continue. So going back to the story, when looking at the documentation that I found that like the sample code was written in C, and it was actually like kind of easy to follow. But I didn't really want to write C, so I was like, okay, is it possible to do TCP socket programming in Ruby? So after a lot of consideration, I just decided to ask my best friend if it was possible. And gladly it was. So Ruby has like, in the standard library, basically a library to support TCP programming. So it's basically just like a lot of bindings to C libraries that do system calls. We'll briefly see some of those system calls that you can do via those C bindings. So kind of like the most important ones is like socket, which will create a socket basically, a reference to a socket. Bind, which assigns the socket to an address. Listen, which kind of activates the socket so that it prepares to receive connections. And then we have connect, which is kind of self-explanatory, accept kind of too. It just like prepares the socket to, tells the socket to accept incoming connection requests. And write, which sends a stream of data or bytes to a pure socket. If you're writing, you probably expect someone to be reading, so that's what read does, just receives incoming stream of bytes or data. Select, which is actually pretty interesting. Select allows for basically doing like socket multiplexing, which is something really important when you're writing a web server, because you'll see that you'll be dealing with a bunch of sockets, and some of them will be busy, or basically they'll be busy most of the time. But when you have this pretty cool method that allows you to do multiplexing, the method will examine will get like basically arrays of sockets doing different things. So we will get an array of sockets that are writing, an array of sockets that are reading, and also like an array of sockets that might have like an exceptional condition, meaning that, I don't know, someone tried to connect to a socket that was already in use. And you can also set like a timeout. So basically this system call will allow you to all the time be monitoring what's going on with your sockets and act based on that. And the last system call that I want to talk about, like I mentioned briefly, is close, which is really important. You always want to close your socket connection. Otherwise, you can run into trouble like the one I had with the microcontroller. So why did I go into all of this if kind of the talk and what I was trying to do all the time is to do TCP socket programming, but in Ruby. So it's like really It's because like of a personal reason. I have always dreamed of being like one of those cool hackers in the movies, like writing really fast system calls and doing interesting stuff. I really tried it, but I ended up looking like this. I hope you have better luck than me. So all of those systems calls I was talking about, they're just like not something that someone came up with because they thought they were a good idea. It's something that comes from something called the Berkeley Socket API, which was invented basically at the same time that the TCP protocol was. And it has stuck since then. Basically, all Unix-based OS supported. Windows kind of supports it. It deviates a little bit from it, but the good thing is I haven't tried it on Windows, but I saw that Ruby kind of supports it too, like kind of wraps that behavior so that you don't notice that you need to do different stuff. The only thing that was different is that you probably want to rescue from different exceptions, but that's not the best. I mean, it's not bad at all, actually. So let's talk a little bit about how the client-server lifecycle looks like when you're dealing with TCP sockets. It's nothing fancy. So when you want to create a connection at a TCP level, you need to basically have two sockets, one that's called like the initiator, another one that's called the listener socket, which in other words is just like client and server. Initiator will be the client, and listener will be the server. So we need to start by creating a server, so you can do the system call that creates a socket. In fact, like I don't know if you've noticed, but I've been putting this number 2 like right next to every system call. Some of you might be wondering why. And that is because like if you go if you use man pages, you'll see that there's two man pages is divided by sections, and like section 2 is basically dedicated to system calls. So if you wanted to understand what those systems calls do, they basically you can basically like just go to your terminal and type man to whatever the call you want to learn about is. Man pages for TCP sockets are really good, so I really recommend them. It's really even better. I mean, it's much more complete than Ruby's documentation for it. So if you want to learn it, check them out. So then coming back to this, you create the socket, then you bind to it, and when you bind, you bind it. When you bind it, you bind to an address, and an address is something that's basically composed of two things: a host and a port. And then when you bind it to one, you start listening. So the server will be hanging there waiting for like someone to connect to them. So then you'll need to create a client. Again, create a socket first. Then instead of binding that socket to like an address, you will just tell it to connect to an address. So this will connect the client to the server, and then the server will normally just like accept that connection, unless it's busy or something weird happens. And then something that's called like the three-way handshake happens. And it looks something like this. So basically, when you're trying to connect, when a socket is trying to connect to a server, it will send like a SYM packet. I don't know if that's how you really pronounce it. And then the server will respond with an ACT packet, just like one packet, basically. And if it goes to the client and everything's OK, the client will respond again to the server saying like, hey, I got your ACK. Here's my ACK. So basically now, like, they just handshake, like the picture we had a few minutes ago, and they're connected. So we continue with the life cycle. So now that they're connected, the client is able to read and to start sending packets of data. And sorry to write. And then the server will be able to read them. and after it reads them, like it can do whatever it wants with them, just basically process their request. And when the request is processed, it will write to the client, responding with whatever result was for that. Then the client can choose to, and it will get ready to like keep reading in case it receives more stuff. Then the client will be able to like just decide to close the connection or maybe try to write again and send more data and see what happens. And then after like a while, it might decide like, okay, I want to close this connection now. So it will tell the server, and the server will just like straight close the connection. So that's basically how, roughly how the like client-server lifecycle works. So we've only seen system calls. We haven't seen any Ruby, and this is supposed to be a Ruby talk, right? So now let's see how this looks in Ruby. So let's start by the server. Let's start like with a really dummy server. So first of all, you need to require the Sockets standard library. And then like there's a bunch of ways to do this. Like the first one is just like create a new instance of socket. It will expect at least two arguments. The first one is called a domain. And a domain can be like different types. So it can be inet, which is basically like IP version 4. It can be inet v6, which is IP version 6. It can be Unix, which it might be useful if you want to communicate like between local processes. And then the second argument, it's type. So a type can be a stream, which is basically when you're like connecting and sending a bunch of bytes. And another really common one is DRAM, which is what you will want to use if you are doing like UDP or RAW. And then there's a third argument, which is actually optional, which is the protocol. It will normally, like usually be 0. It will actually normally be like ignored. It will only have a different value from 0 if you're like using a variation of the protocol, which is not pretty common. So then, after you have the socket, you like after seeing basically what the possible values are. Sorry, if you want to create a TCP socket, you want to use those values to create it. So you want it to be actually like you want it to use IP version 4 or 6. Any of those are fine, but you want it to be a stream for sure. That can change it. Like if you change it, it won't be a TCP socket. So then you can create like an address. So basically with this like method call, this will create like kind of like a C structure to hold the port and the host, and then you can bind to it. After you bind to it, you can just start listening, and if you see there, like you just be able to start listening to incoming connections, you'll see that there's like an argument received on that listen method. The argument basically is the number of, is like how big you want to be your listening queue to be. So this means like how many, so let's say like the socket is busy responding to other requests. So this means how many requests the socket will allow to in queue before it starts responding with connection refusals, basically. So this like number is not, I put a 5 there, which is like the default value for Ruby, but there's actually like a constant that has the maximum allowed value. I tried it on my laptop and it was like 128. It might change, I guess, depending on your system. I'm not sure. But you can set it to whatever you want, basically. If you set it to more than 128, it will raise an exception. And then the cool thing is that like Ruby has some syntactic sugar around this. So you can basically do all the same thing and even a little bit more with this. So basically, you call this TCP server loop on the socket class and pass it the port where you want to be listening. Then you will receive a block, which will like yield two things: the socket and the client. Basically, like the peer socket information. So basically, here we're doing the same thing. We just like started listening, and it's really important that we close the socket before we end the connection, because otherwise the socket will remain open. Like leaving the block won't change. Sorry, won't close the connection. So now let's proceed the client. The client, it's like basically pretty similar to start with. The 2 lines on the top, we already saw what that does. And then on the bottom, we are using just like the connect method, which receives an address. We already saw what an address is. And then like in the bottom, you close it. This has also some syntactic sugar, so you can just use the TCP class method on the socket class, which will yield the socket. And the only thing important there is that you also make sure to close it before it leaves the block. Or you have another option in the bottom, which is just to straight call TCP socket class and instantiate it. So we've seen how to basically create sockets and start like accepting connections and listening to connections if you're in a server, right? But we haven't seen how they like exchange information. So let's talk a little bit about how you use socket I/O. So basically, if you see here, okay. So here we have like WindyCityRails conference server, which in the constructor has like a storage where we store the talks. We start a server there, a TCP server, which will like have accept connections in accept loop. It will take care of them, it will handle them, and then the socket will be closed once we're done. When we're handling connections, that's when we're doing I/O. So we're gonna read from the socket, then we're gonna like save a response after we process it, and we will write back to it like whatever we get as a response. You don't really need to care about what the like process is. It's just it has like a simple API. You can set stuff or get stuff, which are basically talks. In the client, we have you can set a host and a port, the ones that the server has, and then you can like get a talk, get the information, or set it. Where the I/O is like here. We create a TCP socket. We write to it so that we send information to the server, and then we close the write once we're done doing it, and then we read from it to know what the response was. Yeah. Okay, so if we try to run this, yeah, oh yeah, and we're going to start it at like port 3000. Okay, we try to run this. That's an ERB session. We'll see that we require it and call it on the server. Yeah, okay, call the server. It's running on port 3000, and then we'll require the client. There you go. Nice. Okay, so the client's there. So now we'll start by setting the host, I think. Yeah. So the host is going to be localhost, and then we're going to set the port, and the port is going to be 3000, as you already saw. Then we'll try to send data to do some socket I/O there. So first, we're going to set a talk. It's going to be this one. Okay. So it's going to be the 1145 talk. They're using the set talk method. And that talk, it's this TCP socket programming talk. So we're going to set that, and then we're going to, it says that the talk was scheduled. So now we're going to see if it was really scheduled by calling the get talk method, which is going to the server, seeing what's stored on that instance variable where we're recording all the talks. Okay. Okay. So I think that covers the basic stuff that you can do with sockets. So basically, we just saw how you can create a socket, bind the socket to an address, then how you can start listening or accepting connections, and then how you can write to it. So this is like the most simple stuff you can do with sockets in Ruby. There's definitely more advanced stuff. With this, at least you can write like a really simple web server and get started with TCP socket programming in Ruby. So if you want to learn more, there are these 2 books which I really recommend. One that's called Working with TCP Sockets, and another one that's more, like this is really Ruby specific, and the other one is Unix network programming, which is more general, but it's really good to understand like the most important concepts of TCP socket programming. If you, I hope you learned something, and now like you're not like me at the beginning, and you kind of know what you're doing if you ever have to do TCP socket programming. Thanks a lot.